Anna, I see you are available, so I'm assuming you plan on doing the intro.
Yes, hello, nice to see you. I managed to be here, and yes, I can say a few words about Tomasz, if it's the right time for doing it.
Nick, if that's okay with you?
Yeah.
And no, we're gonna do open forum first.
Okay.
And with that, we might as well start the open forum.
I just want to say that it's open forum. I have a lot of questions for forget how you pronounce Zylia?
Zylia.
Zylia. Okay.
Zylia, yes.
Is that a Polish word?
It's actually not a Polish word. The origin is Korean. It's a female name. We pronounce it Zylia, but people in the United States, I guess they pronounce it Zylia.
Right. All right. Okay. And another quick question, Anna. And again, I'm assuming because that'll be coming up would be, for example, you've been advertised in the 19-channel recorder. Is it available?
Yes.
Okay. Through B&W? Or B&H?
B&H, also our online shop. So you can just simply visit our webpage and get it through our shop.
Okay. That's it. I've had some good times looking. I'm a Soundfield user, so I'm anxious about this meeting to see how they compare. So I'm done, Nick, for my questions.
Okay.
Just mention if you spelled Zylia with 2 L's, then people would pronounce it Zylia. The rules of English pronunciation, if there are some.
We can think about this for the second company.
Where are you now, Anna?
So at this moment, I'm in Poland, of course, but in a small city close to German border. It's called Zielona Góra, so Green Mountain. And right now, we have something like our Polish Oktoberfest. It's connected with collecting and producing wine. So if you have 1 week of free time, I invite you here just to taste the regional wines.
Thank you. We're chartering a flight now.
Yeah,
Right. And I see that Barry Ober is on board, and he is an early adopter of, should we say, multi-channel playback sound. Is that the right description, Barry? Barry Ober? I guess he hasn't turned on his microphone. But okay, that's all I have.
Anyone else?
Here we go. I got the right switch.
I can talk about the new BAS speaker briefly.
Yeah.
So the new issue of the BAS speakers come out, and it's the first under my editorship. David Weinberg has stepped down. It's 26 pages long, and it looks more or less the same, but you may notice there's no contributions from David Weinberg. Basically, when he retired as editor, he also apparently retired from most all of his organizations and no longer has contacts to submit material. So we're on our own, and I'm soliciting material. The cutoff is October 15th for the next speaker. So if you submit material, it will appear in a reasonable time. I'm collecting material now. I have one meeting summary promised, which is sort of the backbone of the issue. And so on and so on. We'll see how it works out. That's all.
David, I have a question. You said it was 26 pages.
Yeah.
Did the printer say anything about the cost of the publication if it's not a multiple of 4 pages?
Well, I added 2 pages to my request for printing. Because the pages are there where the user them not a multiple of 4.
Oh, I see. So they're gonna,
Two
okay, 26
blank pages.
pages comes out 6.5, right? By dividing it by 4, or is my math wrong?
Well, it's 26 pages plus 2 blank pages.
Oh, okay. Okay, good. I was just curious because I know David was mentioning about the price of that, and I know we're concerned about pricing. Okay, good. Thank you.
It's been a learning process. For example, color pages for the
Mm.
print version cost 6 times as much as black and white. But it turns out you can specify color or black and white in the printer order. So we can basically make a color speaker for distribution by PDF, and then perhaps downsize it a bit for the print version to save a little money.
Mm.
But it's being paid for by the members, so I'm not too worried about it.
Mhm.
In other words, must the entire issue be in color or just certain pages?
It's basically the only black and white really is Ken Wax agreed to print certain pictures in black and white because he didn't think the color added all that much. But otherwise, everything is in color.
Well,
Except
you
for the
asked,
application.
this is Ken, David asked me
Yes.
to sort of conserve the BAS funds by limiting the color pictures to those which really needed it to convey the message.
That's
And I
correct.
did that
Right.
in my article about the Consumer Electronics Show earlier this year.
Right, and we did that.
So I just got word from CTA that they're now advertising. They've got 1,200 exhibitors for next January. And of course, they've got an exclamation after that, but the fact is it was 4,500 in 2020.
Hmm.
So I think there's probably a fundamental shift in approach to business. I think companies realize they didn't have to have so many of their employees travel, and probably permanently reduce travel budgets. But I'm curious if others who are in some large companies are seeing those changes.
Okay, I do want to mention that thanks to Robert Beam, he'll be our October guest. That'll be in Marlboro, Mass. So it'll be live and probably Zoom. He has made available to BAS members some free admission tickets to Exfonia, which will be in New York. What's that, the 18th, 19th, Nick? 13th,
Yeah.
19th?
It's not Axpona.
Huh?
It's not Axpona. It's a New York audio show, right?
Oh, okay. I've been calling it Exfonia. Is it New York? Well, it is in New York. So is that the official name?
I think so. I'll see if I can find it.
Yeah.
No, not that one.
Sounds like they're dovetailing it with the AES convention.
Oh, is that at that time too?
There's one in October, I believe, in New York City at the Javits Center. I got a notice the other day. Is this it? What time? Come on. No, early bird discount. Let's see what it says here. Oh, come on.
It's October 19 to 20.
Yeah. That's what I thought. Yeah. With additional training opportunities on October 18th and tech tours and networking events on the 21st. Then they're going to have an October 26th and 27th online event to bring separately curated programs of workshops and papers to a worldwide audience. Gosh, it's nice to have two computers. Although I didn't realize
it is the New York Audio Show, and it's next weekend, basically.
Whoops,
I'm having a little,
there we go. Yeah, I was just checking my
their
nice to
web,
have new computers, because I just pulled up their website.
yeah, their webpage has not much on it.
No, I know it.
Under the overview, when and where, it says TBC, and I'm not sure what TBC stands for. To be continued, maybe?
Well, I actually got an emailed notice, and that's what I was wondering about. Let me just look it up.
TBC, could that be the Barclays Center in Brooklyn?
It could be.
No,
It's used, TBC seems to be used in several places.
that's not it.
Like in the exhibitor list, it's all over the page. So don't know what it means. Anyway, it's a smallish show. Under brands and exhibitors, they say 45 brands. That's pretty low. And it has a few, highly recognizable brands, but not all that many. Anyway, I'm considering going down for a day, maybe. We'll see. Where are we? Zoom here. Okay, anybody else have any?
The address is 49 West Street and 32nd. So I'm not sure if that answers that question about which building it is.
The AES convention I know is in the Javits Center.
Right. The New York Audio Show is 49th and 32nd Street.
That's approximately where Javits is.
Yeah, the building is big enough that they were running, last time I was there, they were also running either a SMPTE or an NAB convention as well. And I think my blur keeps freezing. Yeah, it keeps freezing the the video. I do have something else that I stumbled across a while back. It's a nifty little box that's sold through Harman Kardon by DBX. And let me get it in front here. It is a simple little cable tester. Looks trivial, but look at the number of cables it will test. XLRs, RCAs, BNCs, DIN connectors, TRS jacks, banana plugs. It even has a couple of probes, continuity check, and a speaker twist connector. I think that's what it says. Yeah. And the box itself, they even include a couple of test probes in it. I think it's about 30 or 40 bucks. It's a 9-volt battery powered unit, but it comes all bagged up. And this is what it looks like. And it's got all kinds of connectors, as you can see here, on both sides, in and out. And I've used it to check polarities on XLR cables, which I found that one of the Y adapters I had was evidently set up purposely for MS. So one of them was out of phase with the other one. And this little puppy pulled it together well. The two probe points here are for a set of wire probes they give you here. Oop, let me get it into the picture. So you can use them to check continuity, and the whole thing is run in the back here. There's a little door which holds your favorite 9-volt battery. I don't know if you can actually see that. The lighting is a little weird, but there's a 9-volt, standard 9-volt battery, and it works pretty damn well. My only real gripe about it is they used a cheap XLR connector for this baby here. But I wound up, when that one started getting intermittent, because it uses a pincer type contact rather than a conical one that wraps the pin. It turns out that on Amazon, you can get a Neutrik equivalent for it. And that's a real connector. But it's a handy little gadget.
Could you repeat the brand and the model?
Okay, it's called a DBX CT2.
Thank you.
And I think I got this probably from Amazon, if I'm not mistaken. I forget exactly. And I think it was about 30 or 40 bucks. I can
Alan,
just put-
did you just say it went intermittent?
The connector did. The
So you got a new product with the DBX brand on it?
Yeah,
And
it's,
it went intermittent in a few days or weeks?
no, this was probably due to, I was checking out a number of XLR cables on it. And it's entirely possible that I opened up the pincer type. They use a connector, a cheap connector that uses 2 pins and the probe goes in like this.
No, I get it, but
And
it
it's
doesn't
not
seem
new.
like something that should happen no matter how much.
Yeah,
you use
and
it.
it's out of warranty at this point, I'm sure, because I've had it for a while. But it just struck me that it's a very useful little tool. And I brought it, I've been using, I'm working with my church to install a video transmission system upgrade for Zoom services. And I wound up using this. We had to I bought a used audio snake, 12 channel, 75-foot audio snake. And this was perfect to check out all the connectors to make sure they all work. The switch on the front here is what checks it all. And if you switch it through, you get a red, yellow, or green light right here that lights up to tell you whether it's connected, grounded, etc., over all the pins and connections.
As long as it's not intermittent.
Right. And if it's intermittent, it flashes. And there's also a point on the end. If you turn it all the way over, you probably can't read it here, but it's a battery check. So you can check.
It's $59 on Amazon and eBay.
Really? They must have found that people were after it, because I think I paid less than that for it.
There is a cheaper product for $35 called a Mackie cable tester.
Yeah, and I think Behringer has something also.
That's right. I have one of the Behringers. It's not as full featured as the DBX.
Anyway, wonder where that came from.
But that's good to know.
But it's a nice little gadget. And it's, as I say, it's super flexible. You can check, I use 5-conductor cable, XLR cables. Well, lo and behold, this has a 5-conductor XLR connector right here, which is used for a lot of the, oh God, what is it? It's the digital audio studio feeds that they use. I forget what they call it. And it's also used, oh, well, it's right on here, DMX system. And that has a mate on the other side right here. And so I was able to check my 5-conductor XLRs as well to make sure they were running okay. And for the money, it looks like it's very well built. It's a very sturdy box, steel box, all the way around. And I've had it open. It has a circuit card and stuff. I had to replace the connector, but outside of that, everything else works beautifully on it. It's a very nice little rugged box for testing various cable types.
How does it catch the pin 1 problem if it exists?
If you wiggle the connector, which was what I did, I wiggled the connector and the light started flashing up here. There's a red ground connector here for the ground connection on it, if it's there, through the XLR shield. And then there's a green and a yellow. If you get yellow, you're getting not a connection. And if there's no light at all, it's not connecting as you switch through the various positions on it. And it does, I believe, if it doesn't come with instructions, they're downloadable online. Although, what is this? This looks more like it. It's a warranty sheet here.
Maybe DBX needs a tech writer.
No, this is just the important safety instructions. Don't plug it into the basically, but it's in about 14 languages or whatever. It's a fairly large heap here. I think that came out of the bag with it too. But it's a nifty little gadget. I found it useful. Just thought
Ready
I'd
to move
mention
on?
that. I beg pardon?
Ready to move on?
Just one question. What is DBX now? Who owns it? What do they
Harman.
do?
Harman. Harman International owns it. Or as
And
we
it's a Pro company only.
which means Samsung.
Anybody else have anything? No?
Okay, I did find the right little, here's the one-page instruction manual on how to use it. Quick start, and they point up all the details and so forth. So, yeah, there is a manual for it, such as it is. But if you've done any kind of checks or continuity testing, it's pretty obvious how to use it.
Yep.
Next.
Well, if there's nobody else, then I guess, Anna, you should introduce the speaker.
That's right.
Okay, let me introduce Tomasz Zernicki. Tomasz is a co-founder and CEO of Zylia. And of course, Zylia is quite a new company, but very innovative company, which provides tools for 3D audio recording and music production. Tomasz holds a PhD in electronics and telecommunication, and his professional interests concentrates on 360 music production, virtual reality, spatial audio processing, and recording. He's also an expert, and he takes an active role in MPEG standardization committee work, and he has significant contribution to the audio compression standards such as MPEG-D, USAC, and MPEG-H 3D audio. And maybe something from Polish background, he was also awarded by the Polish National Center for Research and Development for outstanding young scientist in Poland. And he was also selected as one of the new Europe 100 challengers and innovators. Tomasz, maybe I'll give you the voice.
Thank you, Anya, for such a detailed introduction. It's a real pleasure for me to be here, and also Alvin, thank you so much for taking all the work to make it happen. So we were discussing for a few weeks or months about this presentation. And yes, so I'd like to share my screen with the presentation. You can also interrupt me whenever you want and ask questions. And just I would like to let you know that if it will be great if you can use the headphones. If not, then also don't worry, I can also send all the videos that I will present after the call, so you can also listen to this in a proper on the proper hardware. Okay, so let me share the screen. Okay, so during this presentation, I'd like to talk a little bit more what are we doing at Zylia. So what is the purpose of the products and solution that we develop, and mainly I would also like to highlight the importance of the audio and 3D audio for so-called right now metaverse, but in general this is from our point of view is we are trying to develop tools that help us to, let's say, teleport to any place on the world and participate in the live event. So maybe also at the presentation we also have our colleague Florian Grond. So maybe I just so Florian is a creative sound engineer, and he also helped me to answer any of your questions. So he was involved in many recordings with Ambisonics and Volumetric audio. But Florian, would you like to also say something about you?
Yeah, thanks, Thomas, for the introduction. Thanks also to be here.
I think, well, as Thomas said, I'm the creative sound engineer. I had the opportunity to record with Zylia technology and mix in the last years. That was a really great pleasure. And I think I'll let Thomas continue with the presentation. But if you have any questions afterwards, I'm happy to join the Q&A. Thanks. So yes, Anya mentioned that a little bit about the company. So I'll just maybe say that we have also the US roots, because our company was founded in or acquired from Telkoria Technologies in 2012, and Telkoria was before the part of the Belcor Labs. So that's quite interesting story about a company, and maybe that's why we also are quite active in US, even if we have a main office in Poland. Yeah, so basically, so what are we doing is we try to, the mission of our company is we try to shorten the distance between the artists and the audience by providing immersive audio solutions. Because we strongly believe that audio, and especially 3D audio, is a key component that recreate the emotions that goes together with the video or any media content. And also about why are we talking about this 3D audio? You know, if we are looking what happened in the last 2 years, especially because of COVID, but that was a huge transformation in the general perceived of how we perceive the 3D audio. And so here is like a short capture of Google Trends, and that we can see that from 2020 we have like a huge interest in virtual concerts, so concerts that happened in the online, or they also happened in the different game platforms like Fortnite and similar. So this is something that is really booming right now, and even if the COVID and the pandemic is not so not hurt us so much like in the past, then still people are interested in this live concerts, because it allows us to choose the different live events that happens almost everywhere. And also, if we looked at the what is going on in terms of the virtual reality, then we see that there is like an exponential growth of sold VR headset devices and devices that support the listening of and participating in the virtual realities or augmented reality, and audio is, as I mentioned, is a very important component of that. And another thing why this topic is important, why 3D audio is right now very important. Also, this is like a part of standardization at MPEG, standardization forum. So MPEG is the same group that develop MP3 and other multimedia codecs. And so we as a company, we're also part of this standardization forum. And right now, MPEG is working on the volumetric audio rendering part. So this is like the key component of it will be a key component of any receiver like VR headsets or smartphone and any broadcast receiver in the future. So that's why, you know, this 3D audio is super important. And but there are still like a lot of different problems. So in terms of 3D audio, this is still like a new maybe it's not new division, but it's like people just starting going to that. They just start learning, and there is still we see that there is a lack of high quality recording solutions, and even there are no workflows for recording 3D audio. Of course, we know Surround for a while, but but then still this type of workflows and setup of microphones, this is not very often not obvious and not scalable, especially it's not scalable. And then if you also think about the setups like for movie production, where we have non-linear production that most of the sound engineers, they use the game engines to produce audio. So this is also not easy and not obvious how to create a sound for Dolby Atmos and loudspeaker setups. So this is another problem with the 3D audio. The next challenge is we have also like a growing number of audio streams, but so far in terms of the streaming, and especially streaming the 3D audio or 360 audio, it's a huge problem, a huge challenge, and how to do that actually, and what are the standards for it. And the last thing is virtual reality, as just mentioned before. And maybe actually in the game development is the probably the part of the market that is the best familiar with creation of 3D audio. And this is something that I would like to focus during this presentation. So how we work with 3D audio, and how we create tools that help people to develop or record the 3D audio for their needs. And as I mentioned, whatever tools we have and provide to the market, is everything is combined somehow to our long-term vision. So you can imagine that you are able to participate in any live event. It can be a concert, it can be a sport event, or something like this, and then as a listener, you would like to decide from which place you would like to listen to this performance. So maybe you like to be in the crowd, maybe you like to be on the stage, or maybe you like to be in any other position where the sound is like the best, or maybe not. And so why doing this? Because I'm also like a great fan of live events, but probably not the only one. We really like to socialize and spend time with other people during concerts. And we are going to concerts because not because we would like to hear the best possible sound, because we can do this at home. At our sound systems, but at concerts we can feel the energy, and the emotions everything is connected with 3D audio, and that's why we also try to build tools that help with this recreation of this feeling and 3D audio. And this is something like maybe a little bit futuristic. But this is also like one of the part of the vision of the component, something that we already provide to the market. So this is the recording of volumetric audio. By volumetric, I mean that as a listener, you can freely decide from each position you would like to be. And this is, it was recorded in Poznań. This is the Poznań Philharmonic Orchestra. And there was like 30 musicians. We also use 30 microphones, but those microphones wasn't connected wasn't put next to the instrument, but they just equally spaced. And during this video, you will see how you can navigate, and in that case, walk around the violin. I just play back this. Okay, so you can hear that we virtually go around this violin, and what is important that the sound wasn't captured by any microphone that was walking around with the camera, but it was just rendered in on the receiver side. So it can be done in the post-production. So you can imagine that we have something like a flying virtual microphone on the stage. Okay.
Could you
Yeah.
play that again?
Sure. I will also have more examples like that, and also provide the audio later on, so don't worry. And yeah, so one of the most advanced and the right now also the main solution that we provide is recording hardware microphones for this volumetric sound, which is based on the Ambisonics model. And also we have software that is able to create this virtual microphones in the space that allows you to create the sound from any given point. But I will also tell this details later on. So maybe a little bit about the solution that we have and the product. So in terms of the hardware, so you can see this microphones here. By the way, I'm also using this microphone right now for this video. So what we have, this is Higher Order Ambisonics, so third order Ambisonics. We use 19 channel, we use the 19 microphones inside this devices, and all of them are digital microphones, MEMS, omnidirectional. And we also use this dedicated cable for the time code input for the synchronization of all the audio. This is not a word clock, but this is enough for synchronization, like hundreds of channels that we are able to capture. And yeah, so there's additional electric indicator that looks pretty nice. And the sampling is 48 kilohertz, 24 bits. And it's USB connectivity, so it's pretty easy to use this microphone. On the other hand, we also don't use any XLR cables, because then you can imagine having 19 or 20 cables going on from this very small microphone. And then if you would like to use like 20 of those microphones, so you can have 400 cables, and this is just a mess. Yeah. So that's why using this USB connectivity is very comfortable. And I think that what is also all of the microphones that comes with this that we sell, they are already calibrated. And the sensitivity variance across the capsules are in the range of 0.1 decibels. And yeah, and so I think that what is important, that I think that there was also like one question from Alvin before this in one of the emails. So we use the digital microphones, MEMS microphones, because they keep the parameters over time. So by one of the most important parameters, if we build the Ambisonics microphone, is sensitivity of those microphones, because because the output of the Ambisonics microphone is, we can say, not the output of the capsules, but the output of the process sound in the algorithm that decode this 90 channel signals to B format. And in order to have a good quality Ambisonics signal, all of these microphones have to be properly calibrated, and they they shouldn't change their parameters over time. So if there are Ambisonics microphones that use the electret or similar or condenser capsules, then usually that kind of microphone array have to be recalibrated every few months. because if you don't do this, then basically you are not able to capture this ambisonic sound anymore because it will be just not correct. Yeah, so what we have this microphones, and also together with the microphones we provide the software that you can edit or record the 3D sound. So we have dedicated plugin that, for example, you can do the beamforming, or you can also decode the ambisonic sound to Dolby Atmos format. And also some of our customer requests from us to have a dedicated recorder. Of course, you can use the computer with any device that you can connect to the USB with the USB. But usually, if you record in the forest or in the jungle, then you don't want to carry on to take the computer with you. That's why we have this additional portable recorder. And actually, this is the only one portable recorder with the USB input and the multi-channel input that is right now on the market. But yes, I would like to go to, before I go to these volumetric solutions, I'd like to say a little bit about the ambisonics. And so basically, ambisonics is a parametric representation of the sound. And it's represented by the spherical harmonics. And the spherical harmonics is something like you see on the right-hand side that we have beam patterns of different orders. And so we can also think like ambisonics, if we put ambisonics microphone somewhere, then we are able to capture the 360 sound in the way that we can extract part of the sound field just from given direction. And this is possible because of this spherical harmonic representation, this parametric representation. So the higher the order of the ambisonics, then we have also more channels, but we also have the higher directivity and higher spatial resolution. And this is very important because you can see if we talk about the first order ambisonics, then basically this is sound that captured like maybe quarters of the sound field. So then if you decode the sound, so you know that the sound source is somewhere more or less in that direction, but you are not able to correctly distinguish the position of the sound source. But then if we go to the higher orders of ambisonics, then we are able to, during the decoding to binaural or multi-channel, we are able to distinguish the exact position of the sound source. Yes. And this is one of the use cases that I like to show because ambisonics is a great tool for capturing the 3D audio and everything that surrounds the microphone. But also what we can do with ambisonics, we can use beamforming to extract just some part of the sound field. So in that case, I will show you this short video. So this is like a panoramic 360 picture where we recorded musicians, and then on the right side we have our software that in the middle we have this physical representation of the microphone, and then we have this virtual software microphones. So what we are able to say, okay, I like to get a sound from given position. And also, I like to change the polar pattern of this virtual microphone. So it can be from omnidirectional to very narrow. So I show you the video. I think this is self-explanatory. Okay, so as you can see and hear, we were able to point on any of those musicians or instruments, or even different part of the instruments, and then extract the sound from this position. So you can imagine that you can capture with just single mic, and then you can create a multi-track recording, and that with just the sound that you defined in the post-production. So this is a also very convenient way. You can also probably hear that there is still like bleed from that we still hear the other part of the instruments even if we do very narrow beam. That's it, because in that given example, we just focus on the best possible quality of the sound without any degradation. And you can still, let's say, adjust the separation if you want. But if you mix the sound, then this bleeds from other part of the room. Actually, they don't have much of the influence, yeah, because at the end everything is in phase and correctly positioned. So this is not a problem if you do a mixing. So at the end you can use this just one microphone or for recording the full band and do the mixing. The other example that I like to show is what is the 3D audio. This is the demo that very often for people is really surprising, because this is the difference between the mono sound, stereo sound, two channel, and the binaural sound. So also two channel, but this is the 3D sound, because we take into account our human hearing and the correction head filters. So during the playback, you hear the sound of storm and rain that was recorded with our microphone, and we decoded this sound from this microphone to mono, stereo, and then binaural. Oops, sorry. I think that I don't have this here, so sorry, I just have to switch to another platform. One sec. Okay. Okay, I'm not sure if you hear everything correctly, but what you're supposed to hear, maybe I explain, is that first we have mono signal. So obviously we hear the sound like in the middle of our head. Then stereo give us the wide image, so we can hear the sounds on the left, right, in the center, and so on. But then if we switch to binaural, then it's like the sounds is a lot more external, outside of our head, and also we hear sounds that comes not only from one plane, but we also hear sounds on different elevation. So that's that's very that's the very important part in recreation.
May I ask?
Yeah.
Was were the extraneous sounds like the siren, were they present in the mono and stereo and just not as audible?
Yeah, they're still present, but you are not able to say from which direction they are coming to you, because you can hear this on the headphones. Okay, you hear some sirens, but in mono you don't know from which direction they're coming. But if you switch to binaural, then immediately you know that okay, this is exactly in the top left or top right or whatever.
So are you saying the sirens were in the mono portion that we were listening to?
Yeah, that was my question. I didn't hear the sirens at all until you went to binaural.
Yeah, I don't think they were.
Okay.
Can you repeat it?
Yeah, sure. But okay, so there wasn't sirens in that part when we have the mono sound.
It wasn't there, right?
Okay, all right. So it didn't suddenly reveal sounds we couldn't hear. Okay.
Okay, so it's also worth to mention that all of these sounds were decoded from the Ambisonics. So this is really nice that you can use one tool and then you're able to have different version of the same recordings. Yeah. Okay, so this is like another use case, and the last but not least is this volumetric sound. I would like to go once again to this use case. So here we have multiple. We have a car, like a big object, and we have also multiple Ambisonics microphones. So in this place. And this is our software that allows you to create Ambisonics position even in the places where there wasn't any physical Ambisonics microphone. So during the playback, you will hear that we are able to interpolate the sound, like recreate the sound in the missing places. And we also are able to like switch between the inside and outside of the car. Okay, so as you can see, we are able to, of course, capture the sound from given Ambisonics, given spots when we have the microphones, but we also were able to interpolate and create the sound in between, and still the sound sounds natural. Yeah. And this is one of the techniques that we right now develop and focus on this. And because it gives you a lot of possibilities in the post-production, yeah? Because then you can imagine that you have this flying virtual microphone that you can put anywhere, yeah? And this is the solution, like, from our point of view, this is the solution from 3D audio. In general, because it's fully scalable, so you can use this multi-Ambisonics recordings and interpolation software to create Ambisonic sound field in any given position. So it means that then you can decode the sound to whatever you want, to mono, stereo, multi-channel, and so on. And so right now this technology is also like a part of I would say under huge evaluation from many different institutions around the world, and this is really really interesting approach to audio recording and audio creation. And in the next slides, I would like to also show you the real audio productions that we did with this type of solution. So maybe once again, so what is this Zylia 6 degrees of freedom or Zylia volumetric audio? So basically you have multiple ambisonics microphones. So this, in that case, we have, for example, 5 third order ambisonics microphones, and this is just for capture, yeah. But then on the you can of course capture the sound with the synchronized audio, and you can have like up to 100 or even more of those ambisonics microphones connected to a single computer. So you don't need any breakout boards and other equipment. But on the post-production side, you also have a software that gives you the possibility to render the sound, interpolate the sound in any given position. And then you can use this for many different purposes, for game development up to studio recording production. Yeah? So maybe just I would like to say how this solution works and what is the technology behind. So basically, usually when we think about the ambisonics, so in the past, especially in the low orders, like the first order ambisonics was used for ambient sounds, distant sound, because of the low resolution. But if we take the higher order ambisonics, like the Zylia microphone or Zylia solution provides, then we, with the simple attenuation curve, we can squeeze, let's say, the sound field around the listener, and then still we have a very good resolution of the sound, spatial sound around the listener. Then if we capture this with many microphones, so we probe the space with a lot of probe the space with the ambisonics microphones. We can, of course, let's say, teleport from one place to another in order to provide this translation. But also you can use additional software that we develop and provide that allows to interpolate this ambisonic field in between of the real physical microphones. So then in terms of playback, so this is maybe more from virtual reality. So how to do the live stream of virtual concerts. So you can imagine that we have multiple ambisonics microphones. Then we use the interpolation software. This interpolation software also can be used for creating like walking paths. And then we can create this visuals in the game engine, and this is the very easy way to create the ambisonic or this volumetric sound or virtual reality experience. Maybe Maybe I'll skip to this one. And this is one of the production that we did with the Poznań. This one was with the Poznań Philharmonic Orchestra. So we used 30 ambisonics microphones. So at the end, we have 600 channels of audio that was captured simultaneously. And for that, we just use, frankly speaking, one computer and the second for a backup. Yeah. So everything was connected through USB hubs to a single computer. And so it looks like this. Yeah, 30 ZM1S and 600 channels. And then what we did, we used the Unreal Engine. This is the for nonlinear processing, and create the visuals of the sound. And also on the right hand side, you can see that how this whole logistics look like. Yeah, so we have the microphones on the stage, or also outside of the stage, And this is right now the sound is also included in the application that you can download. It's application for Oculus Quest, and you can also experience the sound. So maybe also I would like to show you how this work. Okay, I have to switch once again to YouTube. Wait. Okay. I'm sharing the screen. Okay. No, it's not this one. Sorry. Okay, do you see my screen? Okay, so this is the video that was captured during the playback. So we have a guy that walk between the musicians, but all the audio that is presented to you was captured by our microphones and also rendered in this interpolation software. So we have like the real world, and then we switch to the virtual reality. Okay, so right now I will jump to the public, and then what you can hear is that the changing of the acoustics. So in this in this video, so what you can hear is that there is actually like a wall of sound, so maybe it's a little bit hard to distinguish between different sounds, but when we are walking between the musicians, then there is like a more strings or more violins and more other instruments, depending when you are. And also we are able to jump to different locations in this space, and we also can hear the changing acoustics of the whole room. So this is like the possibility, like I mentioned, of this flying microphone that is here. Okay, maybe I'll just switch once again to my presentation. Okay, so this is one approach that is really convenient if you like to create a volumetric sound, and we can also talk about all the challenges, maybe if you are interested, how we did it. But frankly speaking, we're able to set up everything within 1 hour, all the mics, and that's it. So the other approach that Ambisonics can be used for recreating the 3D sound is like a multi-point 360 recording. So in the previous example, so the main challenge was the video, because right now there are no method for capturing this volumetric video. Of course, there are some we can capture, like the small objects or people, but we are not able to capture the full rooms with the volumetric video. So the other approach to creating the, let's say, this navigable sound, volumetric sound, is to use the 360 cameras. And this is something that we did, put microphones and 360 cameras together, and then you are able to, as a listener, you are able to jump from one position to another, and still you hear how the sound is changing, how the acoustic of the whole space is changing, and so on. So here is like an example that we cooperate with Jordan Rudess, Steve Horelik, and Jerry Marotta. And so they meet in, it was actually a really interesting recording, because it was recorded during the huge pandemic restrictions. Maybe not. They met in the one place, and then we record this full. They met at somewhere in the Woodstock in near New York. And everything was operated from Poland. So we have the computers and adjust everything from Poland. So it was really interesting. And still we are able to capture everything within 1 day. So it was huge fun. But okay, so let's talk a little bit about how it was created. So at that room we have one big instrument, which was a grand piano that Jordan Rudess play, and we also surround this with the microphones and cameras, and we also have additional synthesizers that play with from the loudspeakers, and we have the percussion. So during the production of the sound, so we captured the sound from different Ambisonics microphones, but also because this audio supposed to be published on the YouTube and similar platforms. Then we also use the beamforming from this different microphones to add like additional spot mics, let's say, but by using the virtual beamformer from Ambisonics microphones. So in that case, we were able to, let's say, adjust the volume of different instruments to create the more expected, like I would say, sound for the end user. Okay, so maybe I'll show how it sounds. This is just small sample. So we can rotate the scene because it's a 360 video and audio. And right now we jump to another position. Okay, so that's very short. So you can also hear how the sound is changing from the left to right and so on. Also, if you want, we have this recording on YouTube, and there is also like a dedicated Oculus Quest application, so you can experience the full concert. And by the way, if you like to listen to this full experience and full recordings, so we have this application. All the money comes to the charity, to Audio Engineering Society. So I would recommend. Okay. yeah, that's the summary how the recording and processing process look like. So we have we put the microphones and 360 cameras in equal spaces. Then we record with our application, so it's able to aggregate like hundreds of channels from the Ambisonics microphones. And then after that, we can just use typical DAWs and other video or audio production software, because Ambisonics is fully supported by most of the DAWs right now. And you can then publish this audio on different platforms, starting from YouTube to Facebook and others. Yeah.
Thomas, are these links available anywhere for us?
Which one?
The links to the various videos and audios on YouTube. Do you have a directory of those links?
Yes. So if you maybe also share the screen. So if you go to
maybe I will just aggregate them and send you on the chat everything
Sure.
what you need.
That's what I was wondering.
Mhm.
That'd be the best
Okay.
way. Thank you.
We'll do that.
Yeah, thanks.
Yeah, so if you go to if you find Zylia at YouTube, then there is a lot of different videos, and there is also like a sample of Jordan Rudder's concert. I think it's one song, Morning Mist. It's like 7 minutes. It's really great performance. I really recommend because this is not only this is a totally different experience when you listen to 360 audio, because 360 audio give you the possibility to rotate your head, and and we as a people, in order to localize sound, we sometimes have to rotate our head a little bit just to understand from which position the sound is coming. And if you listen to that kind of 360 sound, then you have the feeling of the full immersion of that place. So this is just unbelievable experience. So really recommend to listen on this. And in order to also have a good experience, I also recommend the Oculus application, because the audio there is much better than on YouTube. Yeah, because of the spatial resolution. Yeah, YouTube just is not the best platform for that, but it's probably the widely used right now.
You also have stuff that's on your website as well, right?
Yeah. So if
Demo
you go
stuff.
to if you go to our website, then there is also a lot of videos, and so this is the YouTube. Yeah. So if you go to YouTube and then type Zylia, then you have many different videos. Also this 360. Okay, this is, and we also have a different comparison between different type of recordings, binaural, ambisonics, and so on. Okay, I think that's basically that's the end of my presentation. I have also another slides, and but I maybe I like open the floor for a discussion, because I can talk for hours about the 3D audio. But maybe it will be great if you can ask me about anything right now, and Florian. I think Florian is also much better in terms of answering the question related to this sound engineering of processes of 3D audio.
Okay, my question concerns the roll-off in the low frequencies. Does your software compensate for that roll-off, or what do you lose when you add up that much compensation?
Mm-hmm. So actually, with the low frequencies, that's a very good question. In terms of even if we go with the higher orders with Ambisonics, so we still lose some low frequencies, but still, the lower the frequency, then the localization of the sound is not let's say accurate. So we hear the low frequencies from everywhere, and so if you like to, if there is, let's say, a problem with the ambisonic sound that, I don't know, is cut somewhere, then you can still use the sound from single microphone capsule and boost the sound. But maybe from the practical point of view, Florian, maybe you can also try to answer to this.
So, yeah, I often, if necessary, would maybe boost a little bit the lows, and I'm happy to also share some recordings and mixes that I have done where we had a double bass in it. So I think it worked out very nicely. What Tomasz described is certainly what you can do, but would be a matter of last resort. I would say I never actually had to do it. I was always quite happy with just boosting the lows a little bit. If you like, I'm happy to share one production that was with a trio, a double bass, an accordion, and an alto. And we made 4 movements of this trio, also mixed with nature sounds. So there you can verify for yourself with respect to the performance in the lows. Yeah.
Okay. Is there any? I see that there are also questions on chat, but I have to process them. So maybe in the meantime, do you have any other questions, or maybe you like to listen to this recording that Florian mentioned?
Is the B format output identical to FEMA or AmbiX?
Thomas, let me answer that while you maybe look at the questions in the chat. We have a standalone converter. So usually the workflow would be you record. It can be in a DAW or also through our Zylia Studio recording software. To our surprise, many audio professionals also very much like to record through our Zylia Studio recording software. Then you can export the A format, and then you can convert it into B. And maybe also interesting for you to know, you can also batch convert it in our standalone application, so you can convert several takes, which I find quite convenient. And there you can choose, to come back to your questions, FUMA, and you can choose Ambisonics channel or an ACN, either in the Ambix convention SN3D or in the N3D normalization, so you can cover all standards that are around. And the same we also have as a VST plugin, so you could also go directly from the A format into a VST plugin, and it outputs you 60 channels in any B format you like.
Okay, the capsules cost about $2 to $5 each. Why did you stop at 19 when 16 is all we need for third order?
Okay, good question. If we look at the microphones like a first order, like a sound field, then they use the direct representation of each capsule represent the spherical harmonic. So we have omni and 3 cardioid microphones. But if you, for example, look at the Sennheiser MBO, so then they use totally different patterns, and then you need the additional converter. So this is this is one thing. But then if we go to the higher orders, then it's not possible to recreate the sound, let's say, in the way that it's done with this low ambisonics orders. So what we did, if you look at this microphone, so we have like a rigid sphere, and then we have a microphones around, and then the more microphones you have, then the better also representation of the spatial resolution for different frequencies and directivities. Yeah, and So that's why we have this A to B converters. So we have a format, a signal from capsules, and all of the capsules here are omnidirectional. And then we use the software to convert this A format to the B format. So in that case, we can have like 19 channels, and we convert this to third order 16 channels. And why 19? So this is like a trade-off between, let's say, the number of microphones that gives the best possible, let's say, representation of the third order ambisonics. So that's basically the something that comes out from our research. Yeah, because 60 microphone will not provide you good enough spatial resolution.
How did you get 105 dB signal noise ratio when each microphone has, I think, 69 dB signal noise? How did you derive 105 dB?
Sorry, could you repeat the beginning of the?
Okay, the signal noise ratio of your microphone, I read, is listed to about 105 dB, right? But each capsule, it only has 69 dB of signal noise ratio. So how do you arrive at a higher level of signal noise ratio?
You know, I'm not sure if we, you know,
What is the signal noise ratio of a single capsule?
Signal to noise ratio is 69 decibels. So with this 100, where did you get this information?
I thought I got it from your website. So
Yeah,
you're saying
that's
that,
where it is.
yeah.
Okay. Because there are different parameters related to not only the signal to noise ratio, but also the just checking this.
Well, what is your signal noise ratio? Just for the 19 total capsules.
105 is dynamic range.
Yeah, this is dynamic range, not the signal to noise ratio. Yeah.
So your overall signal noise ratio is 69 dB.
That's what they're spec'd at.
Yeah.
Do you currently have microphones and that portable recorder for sale?
Yes.
That's right. Yeah.
What do they cost?
So you can go to, for example, to B&H website, and we sell the microphones. This is like I think like 1300s per microphones, and it also comes with additional software that I demonstrate to you. But we also have additional microphone, which is ZM1S, so it have additional synchronization input, and it's around $7,000 US.
And these are also listed on the website under the shop heading.
Yeah.
And the recorder?
Recorder is $1,000 US.
$1,353.
Okay, sorry. That was the change.
I got your website here, and that's at least what
Okay.
they're listed at.
Okay.
For your microphone, it seems to me that if you combine the output of capsules, you can gain an additional 12 dB of signal to noise ratio, because the noise adds as 3 dB and the signal would add as 6 dB. So maybe that's how you've improved the specs there.
No, you know, it's not so easy to we don't do improve. You're referring to this dynamic range, right? So this is the dynamic range of each of this capsule. But then if we talk about this ambisonics output, then this is not so easy, like combine the sum of all of these microphones. because they are not, let's say, close to each other. So this is like around 2 centimeters between each of these microphones. Yeah. So for the low frequencies, let's say probably yes, we can have like a higher signal to noise ratio. Yeah. I have a question from the chat that how did you capture the sound from inside the car? So let me just share the screen. So on the, here you can see that we have these circles represent the position of the microphones. So we have microphones outside of the car, but we also have 3 of them inside the car. I don't have any photo of this, but that's how it looked like. Yeah.
You said for the orchestral recording sample that you put up 30 microphones and a spaced orientation. Did those have to be calibrated or something so that the recorder or the software, the processing downstream knew precisely where those were, or did you have to position them that precisely to begin with?
Okay. So it looked like this, that we have the distance between so you can see that this is like a triangles, and the position, the distance between the microphones is around 2 meters, and then actually the position of the microphones doesn't matter, because if you have to provide the position of the microphones to the like an input to our rendering software, and we just use this positioning of the microphones just to simplify the process of providing the position of the microphones. So right now we don't have any solution that will, let's say, automatically find these microphones in the space, but this is something that we are also thinking of. That's why for this purpose we just measure the distances as accurate as possible with the lasers and so on, and then know what is the position of the microphone. Yeah.
Yeah, if I interpret this drawing correctly, you know, you're within a couple centimeters of 2 meters distance, you know, and that's pretty accurate. But it just seemed to me that if you sampled the click and measure the time delays as they progress through the array of microphones, you can figure out where they all are and adjust or compensate for any differences there. So.
Yeah, you're right. So this can be done that way, but from the spatial accuracy, let's say, it wasn't so important to have like a 1 plus minus 1 centimeter let's say the accuracy of the positioning of the microphones, and because if you mix the sound, then you are always able to correct the position, and you can hear to the sound and check the sound that you need. So but you're right, in order to simplify the whole process, it's better to maybe implement some other method. Usually we don't do the recordings with 30 Ambisonics microphones, but maybe 5 to 10. So it's much simpler to set up. Yeah.
Now the output of these microphones is all USB digital feed, correct?
That's right.
So your processing software has to be used to adapt it to 2-channel, 4-channel, 22-channel, 2, etc. Is that the intent? There's no way to actually capture each individual 9 of the 19 microphones on a separate audio track.
It is. So this is like USB audio interface, but with outputs. So if you connect the microphone to the computer or tablet or whatever, then you will see 90 or 20 channel, depending on the microphone, 20 channels audio interface. So then you can use your DAW and just directly use the output from all of these microphones, yeah, if you want, if that's the purpose. So right now I'm doing this, yeah, maybe not all of the channels, but just 2 of them, yeah.
So now this means that you're using some kind of digital audio converter, some kind of DAC.
Yeah, so we use the MEMS microphones. We don't use any digital audio converters inside this. So the MEMS microphone already have this analog to digital conversion, but it's done in the more mechanical way. So this is fully digital microphone. Yeah.
So the bit rates and the frequency speed is like what, 48 kilohertz, 16-bit, 20-bit?
48 kilohertz, 24 bits.
Oh, okay.
So that's a limitation set within the MEMS capsule itself.
No, this is not the for let's say in this implementation of the device, that's the limitation. But there are microphones, MEMS microphones that support higher sampling frequencies.
Okay, because the high res people are going to say, huh, 24, 48, that's nothing.
Yeah.
Sure, of course, but everything depends on the use case. Yeah, if you really need the high sampling frequencies and to use the standard, let's say, miking techniques, then fine. But if you would like to capture the 360 sound, then as I mentioned, the output of the microphone array is the signal processed by the software. Yeah, so then there is a lot of different parameters that came to play, not only the sampling frequency, like sensitivity of the whole microphone array, and so on.
Yeah. Can you display the frequency response graph again with that low end drop? And why is the low end dropping?
So that's the okay. Wait. I'm looking for the slide.
I would expect an omnidirectional capsule to have a pretty flat frequency response. So that's why I'm asking why it falls.
Okay, frankly speaking, this impulse response is equalized. So if you want, I can also send you like a dedicated data sheet from this MEMS microphones that we use. Yeah.
It also looks like there's a brick wall at 22 kilohertz, 20 kilohertz. So that's so limited.
No. That's the problem of that's the problem of this graph.
Sampling.
Let's say, yeah. No, that's the problem of the graph. So we don't have any more data, and it was like incorrect, interpolated. Let's say, it's a visual problem.
Okay, and it's interesting. I noticed below the graph here it says frequency response of a single capsule. So this is not a processed output, but just one raw capsule, I take it.
Yeah, that's right.
I'm surprised to see that 30 dB drop from 20 hertz, 50 hertz to 20 hertz. It's about 30 dB.
This, as I mentioned, this output is equalized, so it's corrected, and this is something that we used in the Zylia Studio application when we just would like to capture the single capsule. But as I mentioned, if you want, I can send the detailed specification of the MEMS capsules after this presentation.
So you're maintaining that all 19, when calibrated or when listened to as an entire microphone, will have the same frequency response as a single capsule?
Yeah. So that's the main thing, because we use the MEMS microphones, because there is like a guarantee by the manufacturer that those microphones has exactly the same parameters. Maybe, of course, they don't have within some accuracy, and but what also is more important, that they don't change those parameters over time. So what we do, we measure all of the microphone arrays during the manufacturing. We adjust the volumes, and basically we calibrate the microphones. And what is coming to you is already calibrated microphone array. So it's have exactly the same sensitivity parameters, and the other parameters are also exactly the same because of the, let's say, MEMS microphones. And then you don't have to care about additional recalibration after some time. Yeah.
Do you have a trial period for potential buyers?
Good question.
Maybe I'll say
Yeah.
a few words about this. We don't have a trial for hardware, but there's a trial for software. And in software, we have recordings made with this microphone array. They are band recordings with a sound source separation, so you can test the software with those recordings, check all the features and parameters on your own. So maybe that will help.
Yeah, we also work with, actually, maybe not, there are some renting studios that they have our microphones. So this is also like an option, but we don't provide this option like directly. There are also some resellers or shops, they offer like this option, but it depends on the reseller. Yeah.
Your editing software, is it similar to what we would get in a software package like Reaper, or is it different than that?
I can show you maybe an example of this in Reaper. Yeah, so we just provide the VST plugins. So then you can use those plugins in Reaper or any DAW that supports the multi-channel. I just share the screen maybe. Okay, so this is an example from Reaper. Yeah, so we have like a single track, but with 19 channels. And then we also arm this this track with our plugin, and this plugin is A to B converter, so Ambisonics converter. So you can set up different orders, and like this channel ordering and normalization and so on. Yeah, you can also correct the position of the microphone. But basically, this is we have a VST plugins and Apple plugins, so that's. If you use the DAW that supports 20 channels per track, then you'll be good. Yeah.
Okay, I use Harpex often, so I'm assuming you would work with Harpex.
I'm not sure. I'm not sure. Maybe Florian, maybe you know.
The Harpex, from if I remember correctly, Harpex is an upsampling plugin typically for first order,
okay.
So you could try it with the first order output of the Zylia ZM1, and you should get some good results. But the idea is that the Zylia ZM1 itself is already higher order, so you don't need to I guess, yeah, it is Harpex. Tomasz, you're right. It is Harpex in hardware, if you will. It is already in high spatial resolution. But what you also can do is there are also plugins out there, free plugins that could even additionally upsample, spatially upsample, even third order. But that's usually very CPU and expensive, and depends on the sound source on whether that sounds nice and works well.
Okay. I've been using Soundfill for some time, and a long time ago, Gerson made all the same claims you're making. So I'm assuming that you're saying yours is better because it has more channels, but lower signal to noise ratio.
Well, Thomas, if I may, so I think maybe it's important to say a little bit like what's really the benefit and the difference between first order, second order, third, and even more, which is that usually with the sound field, all you get an ambience with a limited spatial resolution. The more you increase the order, not only you get a better spatial resolution for the individual sources in the sound scene, but also more importantly, you can better distinguish their depth. So if a sound scene is close to you and you have the near field effect, this is much better represented in a higher order ambisonics microphone than it is in, say, only first order. So so you're gaining on two fronts. First on the spatial resolution, but then also in the sense of the proximity that it can create.
Well, I can certainly agree with you that more mic capsules makes for more three-dimensional sound, but the general public mostly is not set up for listening to either over headphones or anything greater than stereo. So what do you predict will be the projection of the future of 3D audio?
You know, maybe I start.
Okay, yeah, please go ahead.
So you know, the 3D audio is already there, because if you look at what Dolby Atmos is doing, so it's already everywhere, and also in some cable televisions already support MPEG H3D audio standard. So this is also like a multi-channel parametric sound representation, and also if you look at even in the film movie industry, so most of the people right now they switched to non-linear audio processing, so ambisonics, sound objects, and then use the tools like Unreal or WWise, and not Reaper, yeah, so which is linear sound processing. And you know, we also just went back from Redmond. There was a Audio Engineering Society conference related to virtual reality, augmented reality, and 3D audio in general. And there is like people right now are talking about features like better and better immersion of the people, of the sound, and so on, because the platforms are already there. Yeah. So and like you know, for streaming you have YouTube, Facebook, and other platforms. Metaverse, it's okay, it's a huge word, but actually there's like a lot of platforms similar to Metaverse that provide the capabilities for reproducing the volumetric 3D audio, and so I would say that everything is already there, and I also really recommend maybe just recently Dennis Baxter published a book about usage of the ambisonics in broadcasting, and I also recommend this book because broadcasting is right now also really interesting, because how to support Dolby Atmos with during the broadcast, yeah. But what I see is that right now, what's the most challenging is what kind of workflow should I use to support different standards like Dolby Atmos, MPEG-H, I don't know, Ambisonics, and then so on and so on and so on. And I think that the future of the sound are the platforms like, for example, solutions like we provide, because this volumetric Ambisonics domain is very flexible and already supported by many platforms and DAWs, and it allows you to create, like as I mentioned, this flying microphone, and then decode the sound to an output. So I think that everything is going that direction, that the processing will be probably everywhere non-linear, more object and Ambisonics based. And the next phase, I think, is the volumetric audio and sound, because that's the part of the virtual reality, yeah. And you know, right now we can create a game, but game takes months to produce the sound, yeah. But what about the live volumetric sound, yeah? And I think that's the future. How to move the real events to the platforms like virtual reality, metaverse, yeah. Florian, also you wanted to add something. I interrupt you. I cannot hear you.
I have a question about, or if anyone else is done questioning. I specifically am doing, or I'm a graduate student at MTSU in Tennessee, and I'm looking at doing research into XR production and VR production for my final thesis, specifically with third order ambisonics and Unreal Engine. I would like to design and build a digital venue in Unreal where any live concert could be taken and pumped into it, essentially. And spatialization and localization and all these things are close to what you would experience at the concert. One of the things about y'all's digital orchestral experience that kind of struck me, and I feel like is a big obstacle in creating these experiences, is you're sacrificing a producer and kind of a tailored experience for immersion and localization. How do you look at like balancing those two things of, you know, for example, a produced live show with multicam and multi-track audio versus the immersive experience in a 3D volumetric environment? Because you know, it's really hard to beat the immersion and the quality of what's already being produced in terms of those multi-tracks and multicam, you know, products. But how can we compete in the marketplace with this 3D experience when the level of production is, you're not going to be able to produce the experience in the same way?
Okay, try to answer. I'm not sure if I fully understand the question, but you know, also at the Redmond at the AES conference, there was a lot of discussion about how 3D audio should sound, and maybe what's the difference between or you know, what is the artistic point of view, let's say sound designer point of view, and real representation of the sound, because it's like it's very often not goes directly with each other, because like in movies all the sound are faked, yeah. And so it will be great to have maybe like I don't know, that was your question, like maybe the designer view and the reality point of view.
Yeah, that's actually kind of hitting it right on the head of like, you know, I look at like an experience recorded with just ambisonics is not quite good enough yet, and maybe there's things that can be added to it that allows that, you know, sound designer to play a role in that experience. You know.
okay, if you think that the Ambisonics recordings are not good enough, then I really recommend Florian's recordings because they're just amazing, and everything was done with Ambisonics microphones. And but I agree with you that but you know, very often it's really hard to say, okay, what is real and what it's like a studio quality, which is something that we get used to listen to, but very often it's like it's not real, yeah. And then because every sound is like you have this near field experience, like, you know, microphones are close to the loudspeakers and so on. And but on the other hand, we have this reality, yeah, like when we capture sound with Ambisonics, and we have these ambiances and so on. So I think that what we usually do and what we did with this all of this production, frankly speaking, but with the Jordan Rudess, I think this is the best example. You know, it's not that Ambisonics is like for everything, but so what you can do, you can capture the sound with Ambisonics. You have this 360, and then you can also use the Ambisonics signal, but to use the beamforming and adjust the volume of different parts of the audio, like directivity, small or big and narrow and so on. And in that case, you achieve the effect like if there was an additional spot microphone. And then as a sound designer, you have a lot of options to play with ambisonic sound, to change its parameters and so on. But this process is different from, let's say, this object-based or mono sound processing. Yeah, I'm not sure. I don't know. Maybe Florian.
If I may add, yeah, no, I think these are all like really interesting questions. Like when you produce, for instance, something that you've seen in the Jordan Rudess example that Tomasz has shown, when you have 360 cameras, well, then you have to have some way of capturing the sound that kind of is also 360. And then you might want to kind of mix in maybe some close miking if you feel like it, but you would need to have a bass, and this bass can only be something like, if not the Zylia microphone at the moment, there is no other one in third order. So that's just one use case where you definitely need to start with that. But then as Tomasz said, the things that I had produced last year, I made it really from A to Z only with ZM1, so that it's also a little bit of a case study. And I hope it convinces you. But it was like really everything from the close miking all the way to actually the IR. I also made all the IRs as Ambisonics IRs, and all the IRs are done with the ZM1. So also the reverb is all Ambisonics, and it's all ZM1. And so hopefully that gives you an idea of what's possible there. But then the other thing is maybe also one thing that you're aiming at is that I think we don't have. That's still something that's yet to be invented and developed, is the technique that has to come with this type of technology, right? And I have posted one paper that I could publish last March, where we propose, for instance, a wide AB placement of 2 higher order ambisonics microphones, and how that could possibly be mixed. Because that's, for instance, a technique that, if you know, for orchestral recordings or larger venues, that you would want to use to get this envelopment, strong decorrelation, and yet you can still add something by using 2 high order ambisonics microphones on either side of the AB recording. And we propose a way of how you can mix it. We propose a way how you can control the timbre and the relationship between direct sound in the room and so on. So I think that's very exciting, because there's lots of things that we can still work on and that we can still discover.
I'd like to follow up with something Jeb mentioned about the role of the studio producer. We have had Boston Audio Society meetings at Boston Symphony Hall, and in one of the meetings we had the chief engineer who's now in charge of doing BSO recordings since they've taken it in-house. He told us a lot about the placement of the microphones and the position in the hall he's trying to capture in the recordings. And we actually went into the hall on the stage, and he pointed out what he thought was the sweet spot, the seat he likes to sit in when he's listening to the symphony. So if we have the ability essentially to virtually wander around the hall with your audio recording system, we're losing all the value that the production is putting in to the recording. Now, we do have video recordings where the technical director will have the camera shots aimed at the featured player. But I just don't see the value. For example, if we're in the middle of a symphony and there's a flautist highlighted, do we really want to position ourselves standing next to the flautist virtually? Because we won't have the balance of the symphony anymore.
That sounds like a choice for the listener, Ken. One of the things I got into it was not a heated discussion, but it was a very animated discussion about what's been going on with the Star Wars movies from the earliest version, where there have been an incredible amount where Lucas has gone ahead and updated, revised, changed, added, subtracted, done a whole bunch of stuff. There's like 8 or 10 different versions now of the original 1977 Star Wars movie, as he keeps tweaking and updating. And it comes back to composers too. There are a number of composers that continue to tweak their works after they've been released or performed once. They like it, but they don't like this part, so they change it. Case in point, that's probably most dramatic, is Bruckner's symphonies, which have been revised by both Novak and Haas extensively from the originals. And so it becomes a situation where the producer may be the person that is in post-production, or it may be left if the individual listener has the choice. And your point was well taken, because I was thinking, yeah, if you're doing a video of a symphony orchestra, do you want to stand beside the flutist or the French horns or the timpanist or whatever, when that item is either focused in on the camera or is part of the overall performance as a solo portion?
That's a good point, because when the camera is focusing in, generally the audience hears that instrument more prominently because of the way the composer structured the piece.
Yeah, and it gets to a matter of, well, then it becomes kind of personal choice, or do you go back to what the composer intended, which sometimes even the composer isn't too sure of.
And this ability to wander around the hall virtually, many people, unless they bought the top seat in the sweet spot, are maybe off to a side, maybe getting reflections, or being blocked by other people nearby.
I hate to disappoint you, but most of those high quality seats in Symphony Hall are generally willed to the next generation of the family.
By the way, the seat that the technical director liked was the center of the second balcony, the cheap seats.
Wow. Yeah, the John Allen might take it.
Those were the seats I went to on dates in high school when I could buy the $1 tickets for the pops.
But I think we, although it's two different types of content, but what this walk through the orchestra example from Zylia shows, and also what the car recording shows, is that now simply we can go around and we can demo that, of course, with classic music too. What we will do aesthetically with that, this is yet to be discovered. Do we really want to walk around? Where do we want to walk around? Maybe we want a little bit more be on the audience side, or more in the orchestra. We kind of don't know yet. And but I think it's a really nice playing field to try new things. Basically, that's how I see it.
I think the big advantage you offer are film producers who want to move around actors without spending a lot of money on sets. This way they can, for example, there have been movies that have used orchestral settings, but without real orchestras, this would be an ideal solution to positioning the actors virtually.
Or even green screening, and also you have the real breakthrough, I think, is probably in the gaming environment and the virtual reality environment.
So you've done like a Foley for sound. And, you know, Foley is special effects like clomping of feet and stuff, but you've expanded it tremendously.
Well, I think any of us that remember going back to the original Star Wars movie, there must have been movies that did it beforehand, but in the opening sequence, when the spaceship flies overhead and the sound comes in from behind you, and you actually kind of, whether it's real or not, because it wasn't in that many channels, but you get the impression that this thing is coming behind you and is going overhead.
So this is like the Cinerama for sound that gripped the audience attention and got some people almost to vomit over the video.
Well, it's that, but also if you give people flexibility in their virtual reality environment, again, you put on the headset or the mask, and you go at it, it gets to be pretty exciting. And believe me, with what I've just seen, you know, as side views, I'm not really into gaming, but the gaming field is doing some incredible stuff where I think within the next 10, maybe 20 years or less, they won't use actors on the screen films anymore. They will be artificially generated, and the voices and so forth will be artificially produced, because there's going to be eventually the need for voice actors will probably still exist. But do you really need somebody physically on stage when you can reproduce them through artificial intelligence or various algorithms?
No.
I know it's
don't go there.
mind-blowing, John. I know it. I know it.
It's not, you know, it's like Uncanny Valley in video. You know, it's not real and it's freaky. And I don't think artificial voices will ever work out.
Check in a century.
A century. Okay, I'll come back and let you know. But Jeb, maybe you would even know because you're studying this. The big thing is immersive virtual reality. What do you see as a trajectory? Is that really moving forward at a pace that's going to be everywhere? I mean, you know.
Well, personally, I think it's all about cost of production right now. Because, you know, rather than go through a green screen production route, a lot of people are doing XR stages, which, you know, cost like 50 grand a day to rent something like an XR stage to pull off a production. And you're also hiring animators to build an environment in something like Unity or Unreal. So if you can pay the price, what you guys are talking about right now is already there. And the quality is really scary, like we're all fearing. Now, I think audio has yet to reach the same level of, I guess, need. Right now, it's all about video and XR, but the audio and XR just hasn't caught up, in my opinion. For instance, what I think would be a great thing would be able to give the actors or actresses in-ear monitors so that when they perform their you know, act in XR, they're actually performing it in the environment.
They did that in the recording of Les Miserables. They recorded the performances on set, which is highly unusual. The singing was done on set with in-ear mics and lavaliers hidden in the clothes.
But you know, I think that everything depends to what we compare, because if we talk about the game industry, then it's already you know, bigger than music, movies, streaming, and everything's combined. Yeah, and so in a game industry, we already have the nonlinear processing, ambisonics, object-based, and this is already there. So
are you saying the gaming industry has bigger budgets than a Hollywood production?
Yes,
sometimes, yeah.
Of course, it's like if you look at the market, then it's like it's already bigger than, as I mentioned, the movies, streaming, and music, like a CD, like the labels. Yeah.
Yeah, it's bigger by multiples.
Yeah.
The gaming industry.
I mean, I see the visuals in virtual reality being paid attention to, but the audio, it seems to me a lot of people don't give a darn about the audio as much. I mean, I think it's important and maybe it'll catch up, but that's why for your product, I'm wondering in the virtual reality space, how much people really, the average at-home person really cares about the audio to be immersive along with the video. I see a disconnect, but maybe not.
If it depends how you use the what's the experience that you like to recreate. Because if you look on the TV screen, then the 3D audio maybe is not so important. It's like additional feature. Yeah, it's nice to have. But if you play if you go to the virtual reality, like play a game or maybe some other use case when you have to immerse in the sound, then you have to have exactly the same visual and audio cues in order to really be a part of this environment. Because what happens if you see something that is somebody is knocking to the door, but you don't hear this or hear this in the different position, yeah, and that's why also right now the audio is taking is more important, and this also was discussed during Redmond conference that. Like in the past, audio was, let's say, at the end of the processing chain. Like, okay, so right now let's add audio, but right now, because of this importance of the directivity of the sound, position of the sound in the space, it has the exact, let's say, position when designing the whole experience. Yeah, so you have to take also into account how to define the audio, how to create the audio. And you have to do this on the very beginning of the production. Yeah.
I remember attending some consumer electronics shows where I attended a session where sound engineers were complaining that the studio producers were not giving them enough time to do as good a job as they could. And this was back in the 90s or so. In the analog days, they were complaining. Has that changed? Is sound improving in movie production?
I think that depends on the director. John Allen has pointed that out a number of times, that some movies are really well produced because the sound people get in, they have an in, if you will, or at least a respect from the directors. If you don't get the respect from the directors may not care what the sound is. And it also depends on the topic of the movie. If it requires special sound effects or sound, that is important to making the impression. I mean, I come back to this when I was setting up my sound room here in my studio. The fun was I had a little 13-inch professional monitor, standard def, 13-inch. I would play the Balrog scene out of the first version, the standard def version of The Lord of the Rings. And people would not leave after the Balrog scene. They wanted to stay to the end of that movie because they became so wrapped up in listening to what the effects were. I mean, I'm using full-size Klipschorns, and I have a 5.1 surround system with a subwoofer. It's pretty darned impressive to listen to. The thing that's really going to get interesting, and it's already starting to happen, the medical industry is now using holography and virtual systems to be able to analyze and gather together expert physicians and surgeons to three-dimensionally analyze a virtual torso to figure out what's the best way to perform surgery on a patient that has a particularly difficult surgical procedure to do. And so what's probably going to push this harder than anything else from an audio perspective is ultimately the headphones or the face mask will come off and you'll be in a holographic environment, a virtual suite. Instead of having it generated through the mask, it's going to be presented to you in a virtual space, much like the Star Trek, what do they call it? The holography rooms that are talked about in Star Trek, but that's coming. And it's not going to be too long before we start seeing it as a commercial representation in another, 30 years. None of us will probably see, well, maybe some of the younger pups will see it, but most of the guys in the BAS won't, probably, like myself.
I think that's probably the business of future of the so-called metaverse is industrial applications.
Florian, I'm curious, what do you listen to? How many speakers in your own home, for example? Since a lot of us who do recording first listen to it in our, or at least at some point, listen to it on our own playback systems at home. So what do you listen to and how many speakers do you have?
So I sometimes do the premixes at home, just in my bedroom. I admit there I have just headphones, but I can go to a studio at the Center for Interdisciplinary Research in Music, Media, and Technology here in Montreal, where I am. And I did listen to these mixes then and adjust them. And there I have a 5.1, but I have also some speakers for elevation, 4 in total in elevation. So and I have more set up horizontally to have 7. So it's coming close to a Dolby Atmos system. Yeah.
Coming close to what?
Dolby
Coming
Atmos.
close to an Atmos. Yeah.
Jeb, what do you get to use? You're in an academic environment, so you probably have a lot more resources.
I do have a lot of resources, such as an immersive lab, post-production lab, some with like 7.2, 5.1, of course, and I think we have a 22.2 also, which is overkill. But really, I don't look at, I'm consumer minded. How are most people are going to be listening? They're going to be listening on headphones or AirPods or whatever. I want to have the same experience as them. So I don't even bother with any of that stuff, because I'm looking at something that's accessible, something that's lightweight and easy to access. Yeah, easy to access. Like I was saying,
I think every studio owner will, of course, disagree, but I think the figures are that I think more than 70% of people who listen to some sort of immersive audio listen over headphones. So at the very least, you have to check it over headphones, your mix at the end, and that's just a reality.
I don't mean to diminish any studios. I think they're a great tool, and if you can get into a studio and use it, definitely experience it in that way. But I just, personally, I don't have 7.2 at home, so
It's going to end family night in front of the TV set. Unless you happen to buy some of the new soundbars, which are doing a lot of virtual jiggery pokery as well now.
Well, Alan, you bring up the social aspect. If VR can eventually duplicate a live theater experience or a concert or a movie, then we're in our own world and we pump it right into our brain.
What was it? Was it 1984 or Brave New World that had the feelies? Where you put your hands on things and you actually felt what was going on. It's coming.
I think what will be really interesting is that, of course, if you didn't mix for immersive sound, then you would pay very special attention to where you position your sources in the stereo panorama and the timbre and so on. But now, as you listen over headphones, you have HRDFs, you gain something which is space, you lose some control, which is necessarily timbre, because the HRDFs, they do affect the timbre. And we will have to learn how to deal with that and what kind of aesthetics this generates.
I have a few technical questions. In terms of time code and synchronization, when you guys talk about being able to send time code to all your units, is there a centralized unit that you could feed a world clock and time code into that allows, for example, if I was doing a multi-track recording through a interface and I wanted to have that interface of all the direct sources time coded synchronously with all of the microphones, is there a way that you can do that easily?
Easily, I don't know. Okay, but so at the moment the time code works mostly for offline processing. So after the recording, you can we provide a software to synchronize all the recordings, but we also work on the solution that will be that give the possibility to use this time code real time. Yeah. So, but that's how it will work right now. Yeah. So that's my answer.
All right. And then secondly, all the concerts have been all acoustic. There haven't been amplified as far as I can tell. So this is kind of a two-parter. In terms of those acoustic concerts, have you guys experimented with any acoustic systems or things to kind of change the environment you're performing in? Like, for example, record the same piece in a hall with an acoustic system, and then, you know, record it with different settings in that acoustic systems to kind of capture different environments, just to see how well do those work in terms of ambisonic immersion.
Okay, maybe Florian may have a better practical answer, but I just want my comment to this is that, you know, we usually focus a lot on the real representation of the sound as it is here. And if you, for example, take the symphonic recordings, then very often you have these recordings in very nice acoustics, rooms, halls, and theaters, and so on. But at the end, this acoustic is generated through artificial reverb, because you have the microphones placed next to each of these instruments, and then actually you don't have this reverberation is like a fake. Yeah. So what is really nice about the ambisonics, especially higher order, is you get this ambience and room response just for free, yeah, because it's already included in the recordings. Yeah, but it depends on the use case. But Florian, maybe could you help me? We cannot hear you.
Yeah. No, I think Tomasz, you said it all. I think I had shared one recording with you that was Esperanza in Borlaug Hall here at McGill that I recorded I think 2 years ago and mixed it. And for this mix I used several microphones. I also posted a paper that we wrote about it. What was really interesting was that the musicians themselves, when they heard the mix in binaural, they really said like they felt like they were on stage again. And this is of course never completely true, because the way how they are on stage and how they are positioned, that's not how I mixed it. But I think it is the coherence, as Tomasz says, the coherence of the reverb and the room, and that this is all natural and blends so well with the direct component that comes from the instruments, where we could also basically have this really nice near field experience of a higher order recording from the instruments. That's really what gives it this realism that in this case worked so well.
All right.
But just to come back to the acoustic chapter, just because you asked about acoustics, and I think we haven't really answered it yet. And just to say, I think that's a great idea. If you have an access to acoustic system, we have one here at McGill now. The Constellation systems in the new multimedia room. I've heard it already, but I haven't had the opportunity to record anything with variations. But yeah, of course, I would be thrilled to try that, and if you can, go for it.
I don't have access, I guess, readily to any type of acoustic stage, but I think for like XR production or VR production, something like an acoustic stage with ambisonic capture would be a really cool way to change and mold the environment without moving buildings.
That's right. I think that could also, yeah. I mean, if we have in-ear, if the actors have in-ear or the musicians in-ear. I mean, musicians is more difficult with in-ear than, but actors, I don't know. Maybe it's probably the same for both. But we could also, in real time probably convolve with an ambisonics IR and then also create somehow for them, and in a more simpler way, the idea of being in different spaces.
Jeb, it looks like a good insight for you for grad school.
What I wanted to say, I think there have been studies already some years ago. You can study with the same musicians actually how when you give them different, when you put them into different virtual rooms, necessarily particularly they interact with the room and how they play. And it has been studied that this actually changes how they play. And so it has been studied, but I think with the new tools, maybe we can, study other nuances.
Yeah, one of the big things I remember that Leo Baranek spoke about, the late Leo Baranek spoke about in a lot of the calls that were developed that he had studied, it varies because it is dependent very much, especially for orchestral performance, as to what the other musicians hear. When they're playing with a group, they have to hear each other playing in order to make the right ambience or harmonies, etc., flow together. And it varies from performance space to performance space. And it is very noticeable when you go from a very dry acoustic to a very rich acoustic, if you will, like Symphony Hall. The musicians react completely differently to that ambience.
So I'm curious as to why the frequency response of the microphone drops so rapidly below 50 hertz. You know, here we really fight for our 20 hertz response.
That's our reputation, is the low frequency response, the Boston Audio Society.
That's so we're all a bunch of guys.
The upper end doesn't work as well anymore.
So the lowest possible frequency for this capsule is 20 hertz, but this chart, I think this is incorrect, and it's because this comes from equalized characteristics. So as I mentioned before, I can send you this. I have to find this frequency response of those microphones, and then you can check this. But the lowest possible is 20.
Well, there still is a mechanical aspect to even a MEMS device in that you have a small resonant cavity and you have a diaphragm that has to move within that cavity, and it's possible that it just starts rolling off because of the back pressure waves or some such.
If you try to boost that, do you get lower signal noise, or what's the penalty if you try to boost the low frequency response?
Yeah, so the signal to noise ratio depends on the frequency range. So for the low frequencies, the SNR is lower. Yeah, I don't know right now how, but that's exactly how this talk to each other. Yeah. I think that in the use cases when you really need to have the low frequencies, then you can use also additional microphones like Omnis, because at the end also from the low frequencies you don't have this exact directivity of the sound. So then you can just combine this with other microphone techniques. Yeah.
I'll jump in again if that's okay. I was still that second part of my question was amplified concerts. I was wondering if there's been any experimentation, for example, putting a rock band on the stage and having the performance come out of a PA.
Okay, so maybe I answer. I'm. But okay, but I don't exactly understand. So what's your question? So how the microphones behave in that situations, or?
Yeah, I was just wondering if there's been any demos done where you were to take a basically a live concert with a rock band or something with.
Okay. So if you go to so if you go to our YouTube page, then there is I think that quite a few of those that kind of exactly recordings with the rock bands, and also myself, and personally I also have my personal recordings when I also get the microphone put in the first row, and there was a PA system, the band, and behind us there was audience. And those recordings are really nice because if you have the headphones with the head tracker especially, then I have one of the recordings where people start singing, and you hear the people in front of you, or the stage in front of you and the PAs, but then you start hearing the sound around your head. Yeah, so this is really amazing experience. Because what is about the Ambisonics microphone? So if you like to have this real sound from the place, so it gives you the sound. So even if you capture the sound of the noise of the silence in the room, and then you capture this record, and then you put to your home, like you capture this in your studio, then go to your home and put the headphones. Because this is silence, you have an impression that you are at that place. So this is actually really amazing feature of the Ambisonics microphones, that they not fake the sound, and you can do this whatever you want. You can create mono or stereo, fine, but at the very beginning you have this real representation of the sound. Yeah.
Can these microphones be used on actors in performances? I noticed when I first started going to live theater, the acoustics were pretty awful. They used radio mics in the clothes of actors, and they slipped. You heard the clothes rustle. And I've noticed theater audio has improved immensely over a couple of decades.
You know, we had customers, or we have customers that they thinking about setting up this Ambisonics microphones like on the ceiling in the theater, and then capture the sound of this singers or actors. But frankly speaking, at the end, I don't know how this is not our, let's say, our main market. So I don't know what happened with this. But I have one very interesting use case, and maybe I can show you. It's a really interesting story that one of our customers, Hans-Peter Gesländer, I don't know if I pronounced this correctly. He recorded like a puppet show. It was like real actors that were working with the puppets on this big stage, and there was also like an orchestra that played. And it was production for a TV. Everything was captured with just one of our microphones. And after the production, the orchestra said that they will not give the rights to use these recordings. And you know, they already said that okay, so that's the huge issue, because it means that we don't have any sound from this recording, because you know. So what this Hans-Peter did, he used our recordings from our microphone, used the software that we provide for the sound source isolation, and he tracked the position of the singer and extract the sound of the singer from this mixture with the orchestra. Then they went to another studio, record this orchestra separately, and mix everything once again. So they had perfectly synchronized, you know, lips, you know, video with the voices, and also orchestra. Yeah. So if you want, I can playback this for you.
That's wild. That sounds like doing it the hard way, but I guess unions and orchestras being what they are sometimes. Or actors too. Prima donnas, shall we say?
Well, there's the practical issue of installing mics in every actor. I just happened to see a YouTube video yesterday about tech trying to explain to an actor how to put a mic in their hair and make it not visible and yet position it correctly. The tech was getting frustrated, the actor was getting annoyed.
Okay, maybe you know, I will show you this video. Okay, this is very, very short, and I think you find this really interesting. So maybe just share this. Okay, so that was the situation that that was the stage, that 8 by 8 meters, and there was an orchestra here just in front of this stage, and the microphone here on top of the orchestra. And this is the recording, and you will hear the mixture and extracted singer. We will be switching from time to time.
This was all done using just one of your mics?
Yes, just one microphone, but so what that guy did, because in the microphone we have or in the software we have a feature for tracking the moving sources. So he just used this. Then also he used the beamformer that we have included in the software. But then additionally, there was still some additional background music in this extracted voices, and for that he used additional software that just removed this background noises. Yeah, but without let's say this first phase and the beamformer, it will be not probably possible to extract this voice in the quality that was used once again for the mixing. Yeah,
that was impressive.
Yeah, and probably a nightmare for the second orchestra. It's like doing the music for a film to match the music to the film in sync with a live orchestra.
Florian, I have a question about learning curve with loudspeakers. Outside of the headphones, when you get the loudspeakers in a home, understanding or hearing the extra dimensionality becomes extremely difficult and requires a learning process. Do you agree, or am I wrong?
Mostly it requires a really well calibrated speaker setup. And I would say, like, particularly if you record with one Ambisonics microphone, because it's a coincident technique, so you really want everything to be very well calibrated so that it sounds nice and you appreciate it. But then what you can then appreciate actually is that the near field effect really can kind of pop when everything is nicely calibrated. But what I also have done in the recordings that I share, I record with several Ambisonics microphones, the sound scene, and then I mix them together. I apply spatial filters and mix them. So not really virtual microphones, but spatial filters, so as to keep as much of the spatial information, but being able to mix several positions into one. And what that gives me is that gives me sufficient decorrelation between the different sources that I have captured, so that it becomes easier to mix and easy also to separate in a multi-speaker setup and to attribute it to precisely to different positions. And so the learning curve, I think the learning curve, I mean, I've always done it that way, so I'm sorry, maybe I'm not the best person to to answer it. Yeah. Maybe Cheb, do you know something about the learning curve of listening in speaker domes with Ambisonics?
Sorry about that. Not enough to really give a great academic perspective. My experience mostly has been binaural and in headphones rather than in a actual field. I would say, well, actually, I would say go out and look for music that you like or performances that you like. And maybe you've heard in stereo before, and there's been a binaural mix of it, or a immersive mix, and then like try and compare the two, like give yourself a point of measurement. And for example, like Kendrick Lamar's album that just came out in immersive is definitely one of the, you know, I've heard a lot of mixes that are just stereo mixes rendered in binaural. But that one seems they've gone into the detail of really trying to craft something special.
You know, also if you like, we can you can send us an email and we can try to answer all the questions, additional questions, and also I think Agania put the links on the chat, but we can also send later the links to the same link, so don't be afraid, you will not lose this.
One of the other things that happens is most people don't recognize it until it's brought to their attention, but probably the room is the most important acoustic element in the listening system. It has the biggest influence over no matter what type of system you have generally. And unless you are fortunate enough to have it set up right or get a professional acoustician in there to work on the dimensions and such, the resonance setups and so forth, strictly color the sound. And I think even in the professional studios, they struggle with some of that. Although it is remarkable that studio to studio to studio, you can have the same music post-produced. And amazingly enough, the engineers seem to understand, and as Alvin pointed out, have learned the idiosyncrasies, I guess is the word, of that particular listening space. And they can produce recordings that all match. They all sound very similar. It's really amazing.
Anybody else?
I really enjoyed this presentation.
Yeah, this
thank
was
you for
very-
accommodating.
Very good, very stimulating discussion. Thank you. Thank you, folks. It's
Thank you.
very much. You too,
Thank you
Jeff.
very much.
It's nice to see a young pup who's learning the ropes.
Yeah. Or who can teach us a little bit.
Yeah, probably. We all need an education one way or the other.
Right.
Thanks again.
Thank you so
Thanks,
much. Thank you
Tomasz.
for the invitation.
Jeb, is your degree in music or in engineering?
So I got my first degree in philosophy. And my second degree is my master's, which is what I'm currently working on now, is a master's of fine arts in music or in recording art and technique. It is not by definition an engineering degree, but I'm an engineer at this point. I feel like one at least. So there's lots of technical things that I really which were in more focus in my degree, because my degree is rooted in music production, but it has its way of getting into sound for picture and of course XR production. So I'm trying to tailor it to my needs.
Jeb, you're not a member of the BAS, are you? I didn't see you on the list.
No, sir.
Okay, well that's fine. No, that's great. We have a special offer for college students too. So if you want to shoot me your email address, I'll send you a form, or if you want to go on our website, and love to have you be a member. I think you'll find some interesting information there.
Please do. I'll just put my email in the chat, and if anybody has any resources to send me, please send them.
Okay.
Yeah,
Great.
we'll supplement your engineering.
Yeah. And we're always open. You don't have to be a member, but it's nice to be a member. I think you get some good information out of the journal that's being published.
Yeah. And also the Audio Engineering Society and the Society of Motion Picture and Television Engineers. To really drive you crazy. Alvin, it looks like your Sphinx has earphones on.
All right, well, I guess we're done with that. We'll close the meeting. And once again, thank you very much to our presenters and Zylia, sorry. Fascinating stuff.
Yeah.
A lot of fun.
Absolutely.
Thank you.
Thanks, everybody.
Okay, thank you. It
Thanks
was a
again.
pleasure. Bye.
Bye-bye.
Have a good day, everyone.
Bye bye.
Bye-bye.